if you remember from last lecture, right? Suppose this is the last payment, last coupon payment, right? And this is next coupon payment, and this is the second payment. This is a coupon. And we are at time 0. Okay, so suppose that for the time interval for the coupon payment is 180 days, suppose. So one period. Suppose the bond pay the coupon every 6 months, and suppose this is 180 days. This is 180 days. The same, right? In order to estimate the duration, the macro duration, we are at time 0. We look at the first coupon payment, which is on the next one, right? So you can see that it's not equal to one period. It's just a fraction of the one period. And as we have discussed in the last lecture, that if we assume the, let me just use a number. Suppose this is 80 days, and this is 100 days. So you can see that y is equal to 80 over 180, or actually 1 minus y is equal to proportion of the time from 0 to next, which is equal to 100 over 180, right? And because of the time that we estimate, the duration is not, is not at the coupon payment date. So the next coupon, the second coupon payment, is the time period is not equal to 2 because of the first period. It's not equal to 1 period. Right? That's why we need to subtract this part, which is we take into account this part. Okay, that's why we have to 1 minus y here. Okay, y is a proportion of the period of one period of the time. Okay, because if we price the bond at last at the coupon payment, so no problem, right? It's equal to 1 here. But because of it's already 80 days since after last coupon payment, so we have to subtract that part y, the proportion of the period. Okay, that's the same idea for why we have to take the power of 1 minus y, because the time 0, look at the first coupon payment, the next one is not equal to 1 period, right? From 0 to next, which is the first coupon payment, right? From the 0 to next, the first coupon is not equal to 1 period, but it's 1 minus y period. Okay, and 1 minus y is the first part, the first 80 days since the last coupon payment. Okay, and then from coupon, the first coupon to the second one, this is another 1 period. That's why it's 1 plus. That's why it's equal to 1 plus something, or it's equal to 2 minus y. Okay. I think let's have a look at this example. This figure just show another interpretation of the macro duration. As I mentioned, basically we look at the time, okay, from day 0, okay, how long does it take to get the full pay? I mean, in the present value, okay, how long does it take to get the total cash flow paid? However, in this figure, in this graph, not graph, right? This picture, you see that the macro duration can be interpreted as the the center point of the gravity. This is the coupon, right? This is the coupon. This is the last coupon plus the face value. The shaded area here represent the present value of the cash flow. When the cash flow occurs near the zero, the present value, the current time, so the present value is higher than the present value that of the coupon that occur later. Okay, the shaded areas represent the present value of the coupon, the present value of the cash flow, and this is also present value of the face value. So Macaulay relation is just the point that makes the seesaw balance between the left hand side and the right hand side. This is just another interpretation. Okay, but for me, I would interpret like this, that it would take it's the average of time. Okay, when we receive the cash flow. Here is another way to calculate the Macaulay relation. Okay, you can use the closed form formula to estimate the Macaulay relation by using this formula, or you can use this. But this one is just only applicable for the bond that at the time that bond pay the coupon pay the coupon. Basically, we look at the based on the formula, and then we estimate the present value of the cash flow one by one, and then divide by the price of the bond. Let me just explain in detail. In this bond, suppose 10-year 8% coupon, pay every year. Okay, pay every year. The coupon pay every year. The yield to maturity is 10.4. The current price is 85.50. Okay, how to get this? We show you later. On the power 100. Suppose that the settlement is on the coupon payment date. Okay, so Y is 0, no Y. Okay, so you look at it. Actually, you can use the formula, this formula too. Anyway, in order to understand the idea of Macaulay relation, then we can show you like this. This is a coupon received for each year, right? This is a coupon that you receive for each year. The coupon is 8%, pi is 100. So this is a coupon plus the face value. This is the present value, okay? The present value is just divide the cash flow by 1 plus the discount rate or the market required yield, which is 10.4%, right? 10.4. So this divide by. Let me know if I go too slow. I'm not sure whether it's too slow, but based on what you asked during the break, so I'm not sure I should go faster than this. But for the full time, some students just come to talk that okay, why the full time we go faster than this. So maybe depends. As I mentioned, some top. No. On average, full-time student and the flexible not different. I mean, the age of the student is just 1-2 years different. But maybe because you have to work too. Okay, so you divide by 1 plus the discount rate. But for the exam, don't worry because some of you, I forgot to plug in the PowerPoint. Okay, so you just discount all the coupon and the face value like this, right? Until the last one. Okay, you get the present value, multiply, it's up to you. You can multiply this with the time period first, or in this case they just divide this present value with the price first. Weight is just the present value divided by the price. If you look at the formula, okay, you got the present value, no y, so y0 in this case, divided by the price. So right now in the table, it divide the price first, but you can also multiply with the period as well, and then divide the price later. Up to you. Okay, so the weight is just the present value divided by the bond price, current bond price. You get the weight of the cash flow then received from this bond. Of course, in total you get 100% or 1, and then you just multiply the weight with the time period here. Okay. Actually, it's already indicated the period multiplied by the weight. Okay. This 1 multiplied by the weight. Okay, just follow the formula here. 1 multiplied by the weight. This is the weight. 1 multiplied the weight. 2 multiplied by the weight. And 1, 2, this is the period. Okay, so in this case, the period, one period is 1 year. If the coupon pay every 6 months, the period can be 6 months. 6 months or 0.5 year. So the duration that you estimate, it can be, the unit can be years or it can be 0.5 half of the year. So you have to convert. You can see that because this is the weight, right? No unit. This is no unit, right? Because this is dollar, and also you divide by dollar, so no unit for the weight. And then the weight multiplied by the period, and the period in this case, its unit is year. So 7, this is a Macaulay duration, has the unit equal to year. 7 years. Okay. Now, suppose we estimate the Macaulay duration in between the coupon payment date. 6% semi-annual payment, okay, will mature, this bond will mature on February 14, 2022. Settlement date is 11 April 2014. So the coupon payment date, okay, 14 February and another 6 months, 14 of August. Yield to maturity is 6%. Full price 100.94. You can estimate by using the formula from last chapter. Okay, the actual interest, which is by using the 30, the 103, the 60 day count convention. Okay, so you can estimate AI. Okay, Y is equal to 57 days. Okay, I think I have to mention about how to count this. 57 days into 180, so for the denominator no problem, right? Because it's assumed that each month has 30 days, so 6 months must be 180. What about number of days in the numerator here? From the last coupon payment is on 14th of February. It's on 14th of February. And the settlement date is 11th of April 2014. How to count to get 57 days? We assume that 1 month has 30 days. Okay, 1 month has 30 days. So suppose I start from last coupon payment 14th of February. Okay, next month will be 14th of March, is equal to 1 month. Okay, what about next month? No, because 14th of April is already, because the settlement date is 11. Okay, so you can back 3 days to come up with 57, or in another way, because if the settlement date is on 14 of April, so it's 60 days, right? But because the settlement date is 3 days earlier, so it must be 57. Alternatively, okay, if you count until 14 of March, and from 14 of March to 31, actually there are 17 days, but because of we assume 30 days, so you have to count until 30 of March as 1 month, and then you ignore 31st, and then this is up to you whether you which one if you are comfortable with. Okay, so from 14 to 14 of March, this is 30 days. And then from 14 of March to, if you count actual, of course, this must be, that will be 17 days, right? From 14 to 31st of March. But because it's assumed only 30 days per month, there is only 30 days per month. So in this case, for this would be only 16 days. And then from 30, from 30 to 11 of April, there will be only 11 days. From 31st of March to the 1st of April is 1 day. Okay, and so on. Okay, so you can estimate number of days, 57 divided by 180 to get Y, and then multiply by the coupon, dollar coupon payment, $3. Okay. So you get the full price and the flat price. Once you know the full price, okay, now we know the full price, right? Full price is 100.94, right? The 100, sorry, 100.94, okay? This is the full price, 100.94. Time to receive, you can see that it's not equal to the period, because time to receive is equal to 1 minus Y. And Y is did I calculate Y? 57 over 180. Point 316. Okay, so time to receive is 1 minus Y. Okay, just follow the formula, this formula. 1 minus Y, Y is 0.316. So this is 1 minus Y, the period minus Y, right? So this is 1 minus 0.3167. And so on, 2 minus Y, 3 minus Y, until 16 minus Y. Because this is the semi-annually, right? Coupon payment. And then the present value, okay, you discount $3 by 1 plus the discount rate over 1 minus Y, or time to receive. Okay, just follow this formula. Okay, just follow this formula. So you can estimate PMT discount by 1 plus R 1 minus Y and so on. Oh. So the present value, this one is equal to 3 divided by 1 plus the discount rate is 6%, right? 6%. 6.6833. Okay, the present value is equal to 301 plus 0.03. Ui. Okay, 1 minus y. 1 minus y. And then the weight is just the same. Divide the present value with the full price here, you get the weight. Okay, the weight is just present value divided by the full price. Okay, the weight is just the present value divided by the full price. And the time this case is time to receive, not the period. Okay, the last one is 0.6833 multiplied by 0.02913. 0.02913. Oh. Okay. Okay, so take the sum of the last column, you get the Macaulay duration. Okay, the last column is the Macaulay duration. However, because you have to be careful. I'm not sure whether in this room there is any, electric wire in the underground. I'm not sure, but in the financial laboratory, you are not allowed to drink water because of, in the underground there are so many electric wires. So that's why they're not allowed, because there might be some, problem with. Why the change over time not possible? Because the problem is just for the first period. You can look at this, right? You look at this, you can see that the problem is just for the first period, and after that you can see that the time period will be the same, right? From the first coupon to the second to the third, it's only the first one. Okay, this Macaulay duration, okay, the unit is in half year. In half year. If you want to convert this duration into year, so you have to divide by 2. Okay, because of the coupon payment is occur every 6 months, so you have to divide by 2 to get the Macaulay duration in year. Okay, because this bond has the maturity equal to 8 years, right? 8 years. So it's impossible that the Macaulay duration is greater than the time to maturity. Okay, so this unit is in half year, so you have to divide by 2 to get the duration in year. Okay? This is the closed form formula that has been derived by one academic. I'm not going to talk in detail how to derive this formula. Anyway, this formula can be used to, however, make sure that you put the correct number and you know, carefully calculate the number. Okay, so right now we have a few formula. Either one of these can be used to calculate the macrolate duration. Okay, you can use this one. Okay, or you can use this closed form formula too, or you can just step by step doing like this also, but it takes time. Okay, it takes time. We have three, but actually just eventually yield the same solution. This is a closed form one. You don't need to just step by step or calculate all the coupon. You just plug in this information. R is the discount rate. Okay, let me just explain a bit more about the definition of the variable because sometimes it's mixed up. R is the yield or the market required yield. Okay. N is the number of the period. Big N, the capital N is the number of the period. R is the coupon rate. C is the coupon rate. Okay, C is the coupon rate. And Y is the proportion of the day between last coupon payment to the settlement date divided by number of days in between the coupon payment date. Okay, Y not the yield. In this case, Y is the proportion of the day. Okay, between the last coupon payment to until and the settlement date divided by the number of days between the coupon payment. Okay, so you can use this formula as well. What you have to be careful is make sure that you put the correct, number, and sometimes in the quiz, because you just plug in and then in another row you told me the answer, and unfortunately you got the wrong one. So I have no idea, from this why you got the wrong number. So it's up to you. Okay. Anyway, if you got the correct answer, you get the full mark. Same. Okay. Don't worry. You can use any formula. Okay.
X is multiple.
Sorry. X is the multiplication. Yeah. C multiplied by this. Should I just ignore this? I'm not sure. And sometimes I think I have to put this, but sometimes not sure whether should I put the multiplication sign here. Don't forget that, okay, if the coupon occur more than one time a year, so you have to, convert all of the coupon payment, the coupon rate, and also the yield as well. And if I ask you to estimate the macrolate duration in years, so you have to, don't forget to divide by number of the period that pay the coupon in each year.
Going back to the previous formula.
Which one? This one?
Yes. Based on the example, the coupon rate will be 0.03, right?
The coupon rate,
Or 6.
no, 3.
So in this case, the yield to maturity and the coupon rate is the same.
For the yield to maturity and the coupon rate is the same. I can't remember, let me check. The coupon rate is 3 and the yield is 3, yes. But the price not equal to par because of the AI. Okay, any other question? Okay, now we move on to the modified duration. This is the one that we will use in order to estimate the bond price volatility. Okay, the bond price volatility. As you can see from this slide, modified duration is equal to calculated duration divided by 1 plus y. Here is the yield. Sorry, because this is I use another textbook. Y is yield. Okay, I already indicate in this bullet that y in this case is the yield per period. YLR is the yield per period. Okay, so the modified duration is equal to calculated duration divided by 1 plus the yield per period. The modified duration can be written as this formula. You can see that basically the modified duration is equal to 1 over P. P is the price of the bond, multiplied by the first derivative of the price of the bond respect to the yield. Okay. Or in the discrete formula, you can see that it's just the difference between the bond price given the change of the yield over the change of the yield. Okay, here is the difference of the bond price, and here is the change of the yield. Okay, and then divide by price of the bond. The minus is just represent the inverse relationship between change of the yield and change of the bond price. When the yield increase, bond price decrease. When the yield decrease, bond price increase. That's why we have the minus sign to show the inverse relationship. Okay. You can see from this that if the yield increase, so this term will be lower than this term, right? And eventually that will be have the effect, right? Yield increase, bond price decrease, right? Okay, here is the example how to estimate the modified duration. Just another example. Actually, you can use the calculated duration formula and then simply multiply by 1 plus the current yield. Y is the current yield. Okay? Or here just, the other way that we can do by just, step by step perform the calculated duration and then simply multiply by 1 plus, divide by 1 plus the current yield. Let me just say again on this. Y is the current yield. Okay, Y is the current yield. Current required yield. Okay, so this table actually quite the same as the previous table, previous example. Okay, the period. In this case, suppose that we estimate the bond price at the coupon payment date. So the Y or the proportion of the time is 0. So in this case, you can see that the bond pay the coupon 9%, but it's paid every 6 months. So the cash flow is 4.5, 4.5. The time to maturity is 5 years. However, the number of period is 10. Okay. And then you estimate the present value of the $1. Basically, just this is maybe slightly different, but eventually just yield the same. It's up to you. Just a step. You do this first or you the other one first. This one is just estimate the present value of $1 or the 1 over 1 plus 10 to the power of n. Okay. It's just a present value of the discount factor. Okay. And then multiply this with this to get the present value of the cash flow. Okay, this is just the present value of discount factor. This is just 1 over 1 plus the discount rate is okay 4.5%. Okay. So for this one, it's just 1 over 1 plus 0.045 10 to the power of 1 equal to this. This is 1 over 1 plus 0.045 10 to the power of 2. And then for when you get this, you just multiply by this. You have the present value of the cash flow. Okay. Then the present value of the cash flow multiplied by the time period. So in this case, maybe it's slightly different the step, okay, but actually just the same. In this table, basically, they do not divide each cash flow by the price. They just, divide later. Basically, they just do the numerator like this and then divide the price later, just one time divided by this. Okay? But why in this case 0? So what we have done right now is, the cash flow, the present value of this, multiply of this, and then we multiply by the period. Okay, so you get, this is 1 multiplied by this. And so on, right? And then you take the sum, you get the numerator and divide by the price of the bond, 100. In this case, because the yield and the coupon rate the same. You divide this by 100, okay? You divide the sum, the numerator, by the bond price, 100. You get the macaulay duration over there.
Multiply by period means that it's the reinvestment of the previous.
For this case, maybe it's a bit hard to interpret. Maybe this example may be easier to interpret. This one. It's just a step. So in the step in between, I'm not going to explain that, but it's just it's just a work in process. But in this case, you can see that this weight is just weight of the money. In this one, it's maybe easier to interpret. This is the weight of the money because this is the present value for each cash flow, right? And then you multiply by the price. So this is the weight of the money for each time, and multiply by the time period. But this example different. They divide the price later. So this is the present value and multiply by the time. Okay. If you look at this picture, it's just like this. The time, right? Divided by the present value of this. In physics, it's just like you multiply the weight, then you put in the seesaw, and you multiply by the length from the center to okay, this is the total, the total sum of the numerator in the formula, and then divide by the price, you get the macaulay duration. And as I mentioned, because this bond pay the coupon every 6 months, so the unit is half year. In order to get the the duration in year, so you have to divide by 2. Okay, these two to convert the duration from half year to be a year. And then we divide by 1 plus the current yield, which is 4.5%. So you get the modified duration 3.96. Okay, so the two we convert half year macro duration to be year the year duration, and then divide by 1 plus the y, the current yield, okay, because initial yield is 9%, half year 4.5, right? This is just another example. Okay, basically just the same thing. But in this case, the coupon rate is 6%. What you can see here is that the duration will be, because of the coupon rate is lower. Okay, the coupon rate is lower, so the duration is the duration will be higher if you compare this duration with the previous one. You can see that because this coupon rate is lower, so the duration will be higher. Okay, 8.27, right? This one is 8.69. This duration will be higher because of the bond paid lower coupon rate. Okay, the way to calculate this just the same. Okay, the way to calculate this just the same. Still, we still cannot apply the idea of duration for estimate the change of the bond price. Okay, so it's one more step. In order to estimate the change of the bond price, we do change of the yield. This is just provide some more detail about how to convert, the duration from half year to the duration in year. And this is just another formula. There's too many formulas. You just, pick one that you are comfortable with. But in this formula, it's just, derived in another way, but and can be used only for the bond valuation at the coupon payment date. Okay. Basically, just as you know that the price of the bond equal to the present value of annuity, right, plus the present value of the face value, and then we take the first derivative of this bond price respect to the yield, and this is the result of the derivation. Okay. Basically, it just comes from this formula, if you remember the PMT of coupon, right? This is the annuity formula, right? In this case, they just assume 100 equal to the face value. Okay. This is the price of the bond, right? C is the perfect the annuity, the coupon over yield. Okay. I used to write Y in the bracket, but in this case, I just want to move Y into the front to make it close to the result of the derivation. Plus the face value, in this case, it just assumes face value equal to 100 over 1 plus the yield, take to the power of n. And then we just take the first derivative of the price respect to the change of the yield, dp over dy. Okay, and then we get this. There are so many formula. So it's up to you to use, okay? This is another one that we can do, but this is the approximate formula, the approximate modified duration formula. In this case, we will, re-estimate value of the bond given that the yield decrease for some certain level. Okay, suppose the yield decrease 50 basis point, how the bond price change. So you re-estimate the bond price. When the yield decrease, you get the price of the bond. And then you assume again when the yield increase and re-estimate value of the bond. Okay, and then divide by change of the yield multiplied by 2. And this is the, actually it's just a dp over dy, and then you multiply by p to get the modified. Look at the graph here. This is the other way to estimate the approximate duration. When you take the first derivative of price of the bond respect to the yield, actually we try to come up with the slope, right? The slope, the first derivative basically is just the slope of the of the bond price respect to the change of the bond price and respect to the change of the yield, right? This is the slope that comes from if you take the first derivative of the bond price respect to the change of the yield. So we try to estimate this slope. Basically, we try to estimate this slope by assume the change of the yield. Okay, based on the previous formula, you can see that if we are currently at this point, the current yield, and then we assume that the yield decrease, and then the bond price increase to this. So you get the new value of the bond when the yield decrease from this to this. The current yield is here, and then this is the current yield, right? And then we assume that yield will decrease to this. Re-estimate the bond price, you get PV minus the bond price increase to PV minus. And then re-estimate the bond again if the yield increase to this. Okay, to get PV plus here. Okay, you get this point, you get this point, so you get delta P, right? Delta P, which is change of the price, and then you know delta V, delta Y, right? Delta Y, and you can see that delta Y must be multiplied by 2 because it's on the right and the left. That's why we have to multiply by 2 because delta Y to this and delta Y to this. So that's why it's equal to 2 delta Y. Okay, because from the current yield you change to the right and then you change to the left again. So from this to this is equal to 2 delta Y, right? So you have delta P and delta yield. So this is the slope, right? And this is the slope. This is the slide that we should finish the class. Just give me the warning, huh? Okay, so what I want to say. Okay, just want to show you that, okay, based on the modified duration here, right? The modified by definition is delta P over delta R or delta Y, and then multiply by 1 over P again. So right now we approximate delta P and delta Y, right? Delta P, this is delta P, this is delta Y, and then we have to multiply by 1 over price or 1 over PV again. This is the approximate formula, but it takes more time actually. You have to re-estimate the bond price 2 times. When it increase, you increase, yield decrease. Okay. And the result is just the approximate number, not the actual duration. Okay. Now let's see the application of the modified duration. Based on the modified duration definition, okay, modified duration is equal to minus 1 over p delta p in discrete term, okay, delta p over delta r or delta y, okay, delta r or delta y. So you want to know the change of the bond price due to change of the yield, so you just rearrange this formula to get, the formula in the slide. Delta p, okay, over p, and then we move delta r or delta y to the other side, okay. So you have delta p or dp over p, right, the price of the bond, equal to the modified duration minus just, the relationship, the inverse relationship, multiplied by dy or dr, okay. And this is the change of the bond price given the change of the yield here. You just plug in the change of the yield and then change of the bond price. Okay. For example, basically this is just the same, right? Basically just convert to the unit. In this, maybe just in the decimal, then you convert in the unit, just simply multiply by 100. That's all. Okay, so in this case, you can see that if the yield change 10 basis point, okay, suppose that the duration of this bond is 10.66. This is a modified duration, modified duration to be specific, not the macula. This is already the modified duration. Modified duration, delta y, 10 basis point. 10 basis point is 0.001, right? 10 basis point is 0.001. And then multiplication of this, we get minus 1%, about minus 1%. The actual is very close. You can see that this is the actual. If you use a full valuation, okay, you re-estimate value of the bond price by just change the yield, okay. This is the actual change, 1.06%. This is the approximate by using the duration, okay, 0.066%. Now let's see if the change is very large, not only 10 basis points, but 2% or 200 basis points. If you use the duration, you can see that based on the duration, it will predict that the bond price will change 21%. Okay, 21%. However, if you use a full valuation, get the actual change, it will be 18%, different. Okay, the different. Okay, this is the approximate, this is the actual one. You can see that it is quite different. The reason is, when you use the duration, okay, look at this graph again. This is a property of the bond price, right? Someone asked me how to construct this bond price. The relationship very simple. Just assume the coupon rate, assume the time to maturity, and then you just vary the yield and re-estimate the bond price. Then you get with this graph. Okay. Now you can see that when we estimate the duration given the current yield, you get this slope. However, different yield may have different slope, right? So duration will change, given the change of the yield too. Anyway, given that the current yield is here. Now, if we assume that the yield change, okay, in a very, very marginal means very small. The increase or decrease is very small. You can see that the error predicted by the duration, which is based on this slope, and the actual based on this graph would be very close. However, if you look at the change is very large like this. Let me show you that. If the yield, from this current yield, it changed to this. You can see that, from this current, okay, suppose to this. You can see that if the yield, the current yield is here, and then we want to know if the yield increase to this point, how the bond price change. Based on the duration, it will predict that the change of the bond price will be based on this line. So the bond price will be here. And then you can see the percentage change of the bond price given the current bond price here, and then the expected bond price here given the yield. However, if you look at the actual one, the bond price should be only here. This is the error. Right? This is the error. Okay, you can see that the actual is the bond price decrease, yes, but not like this, not much like this, but it's only here. So this is the error. Same idea when the yield decrease, the bond price increase, based on this line, the tangent line here. But the actual bond price actually increased to here. So this is the error too. This is the error based on, the duration. The bond price change estimated by the duration. So duration will work well if when we assume the change of the yield is very marginal, small. As you can see from this example that when the yield change 2% more from the current yield, you see the difference, okay? It's 21 and actually it's only 18. But when the change is small, like this, 10 basis point, only 1.1%. Almost close, right? It's almost close. Okay, so the duration can be used, okay, to predict the change of the bond price when the yield is changed only a little. But when the change of the yield is quite large, duration is not enough. You need one more parameter called convexity. Okay, the convexity will be help to reduce the error here. So basically convexity would capture this error. Okay, convexity will capture this error. Alright, this is just another formula to show the. Suppose that you, instead of knowing the percentage change of the bond price, but you want to know the dollar change, okay, of the bond price, you can just adjust the formula slightly based on the same formula, right? dP over dy equal to the modified duration multiplied by p. Or by the definition of modify is just dP dy over 1p. You just rearrange a little bit. Here we get the dollar duration. Okay, the dollar duration basically just equal to this one. This is called dollar duration. And then you want to know the change of the price of the bond, right? So you multiply the dollar duration with dy. Okay. So based on this, you can estimate the dollar duration if you know the price of the bond, right? You just multiply the modified duration with the price of the bond. Modified duration multiply the price of the bond, you get the dollar duration. When you get the dollar duration, multiply dy again, you get the dollar price change of the bond. Okay, last Sorry, maybe we should finish around here. The property of the duration, okay, the property of the duration. As I mentioned a little bit that the maculated duration represents the time, okay? So for the modified and maculated duration, the 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 number or the value of the modified and maculated duration will be lower than the time to maturity. Okay, only one special case that for the maculated duration of the zero coupon bond is the duration, the maculated duration of the zero coupon bond will be equal to the time to maturity. Okay, but for the coupon bond, the maculated duration, modified duration will be lower than the time to maturity because you receive some cash flow. But for the zero coupon bond, you receive nothing until maturity. That's why the maculated duration is equal to the time to maturity because you receive nothing. Right? Property of the duration is just consistent with the property of the volatility. High low coupon bond. Low coupon bond has higher volatility, right? We have talked about this. So the same, okay? High low coupon bond. Low coupon bond will have higher duration than the low coupon bond will have the duration higher than the high coupon bond. Okay? Time to maturity, of course, longer time to maturity, we have higher duration. Oh, one more thing before I forget. Some students came to me and talk about this relationship. In the exam, because there are so many factors may affect the bond price. So in the exam, when I ask, okay, when this change, how it will affect the bond price, you have to assume that other things that not mentioned held constant. Okay, this is the basic idea when we talk about the or discuss about the relationship between one thing and the other. Understand what I mean, right? How the high and low coupon bond, each one will have higher volatility. We assume other thing constant. The risk just the same between the two bonds. Requirement of the return of these two bonds the same. Yield to maturity the same. Only the coupon rate different. Okay, time to maturity also the same if we compare different coupon rate. Okay, and which one would have higher volatility or which one has higher duration. Okay. Lower coupon bond already mentioned. Longer maturity has longer duration too. This graph just shows the maculated duration in different bond coupon bond, the different coupon payment. Okay. You can see that for the zero coupon bond, as I mentioned, this is a 45-degree linear line. When the time to maturity of zero coupon bond equal to 10 years, maculated duration of zero coupon bond will be equal to 10 years. The 5-year zero coupon bond is maculated duration also 5 years too. You get the 45-degree linear line here. For the perpetuity bond, okay, in case of no embedded option, you get this line, the maculated duration will be equal to 1 plus R over R. How to get this? You can use this formula. This one. In case of y equal to 0, you price the bond in at the coupon payment date. You can see that this term will become 0 when n the periods go to infinity. This term becomes 0, and you have maculated duration of perpetual bond equal to 1 plus R over R. This term will be 0, and this we assume that we price the bond at the coupon payment date. Okay, and of course the discount bond, as we have mentioned, right, low coupon bond has higher duration. So in this case, you can see that given the same time to maturity, bond that pay higher coupon bond, we have lower duration. Okay. In this case, premium bond, which is a bond that pay higher coupon rate than the yield, right? And discount bond is a bond that pay the coupon rate less than the yield to maturity. So you can see that same time to maturity, discount bond has higher duration, the macro duration. Good. Right? Same time to maturity. Zero coupon bond has the highest duration, followed by discount bond and the premium bond. For the perpetual bonds, it's just constant term because it's pay the coupon forever. Okay, I think we have to stop here. Alright, so that's all for today. So for the quiz, it will be covered, from the first two lectures, and for this lecture, you stop at this slide. Okay, stop at this slide. The quiz will be both the multiple choice quiz and also some problem solving question, maybe one or two questions, the big question. Okay. Again, you can bring anything. The financial calculator, don't forget to write down the detail or the input if you use the financial calculator. Okay, what the function you use and what is the input for each button that you put in. Just write it down. You not just give me the solution, okay? You just write it down the detail of how to come up with the solution when you use the financial calculator. If I have time, I will upload some exercise, okay? Because right now, it's in the end of the year. I'm not sure whether I can upload this in time or not.